Now, the second part says ABCD is a kite by using the diagonals. We need to prove that this is a kite by using the diagonals. Now, obviously, we have two diagonals here, AC and the BD. So, both of these diagonals, they bisect at each other at 90 degree. So, the longer diagonal cut the shorter diagonal at 90 degree here. Now, so first of all, we need to prove that the AC perpendicular to BD, and I show you after that what to do. So the first of all, I need to take the gradient of AC, and I'm gonna apply the formula, gradient formula, y2 minus y1 over x2 minus x1. Now I have to take this is my x1 y1, x2 y2. This is A and C, diagonals A and C. I need to take the gradient of this diagonal and I plug this value into this formula. So y2 minus y1, minus 1 minus 4 over x2 minus x1, 7 negative 2. And I must simplify, it's going to be negative 5 over 5. The answer is going to be negative 1. Now I need to take the gradient of BD. This is my second diagonal, x1 y1, x2 y2. So y2 minus y1, 4 negative, and this is negative 5, negative become positive over, and x2 minus x1, 7 negative become positive 2, and this is going to be a 9 over 9 is going to be equal to 1. Now, so the gradient of AC multiplied by the gradient of BD and must be equal to negative 1, because we need to prove they are equal to 90 degree. So AC is negative 1 multiplied BD is 1 is equal to negative 1 must be, and they are equal to negative 1, as you can see. So which means AC perpendicular to BD. Therefore we can say AC perpendicular to BD. So which means both diagonals, they bisect each other at 90 degree. After we prove that AC perpendicular to BD, they cut each other at 90 degree, and now we need to show that the BD passes through the center O. Now obviously the shorter diagonal always is going to be equal in length, and the longer diagonal is not going to be equal in length. Have a look here, because this is a long one. It can't be this side is short, this side is long, and but this one is shorter diagonal is by the center O. So you can see this one is even. So now the shorter diagonal, always you must take the midpoint of shorter diagonal. So we need to find the coordinates of O. So find the midpoint of AC. Have a look here. Midpoint of AC. So the midpoint of AC, I'm going to use the formula x1 plus x2 divided by 2, y1 plus y2 divided by 2. My A coordinates is 2 and 4, and the C is 7 and negative 1. This is my x1, y1, x2 and the y2. I plug all these values into this formula. So 7 plus 2 over 2, and that said y1 is 4 and negative 1 over 2, and this becomes 4 5, and this is gonna be a 1 5. So we find the midpoint of AC. Always when you need to prove the kite using the diagonals, then always first you need to prove that the both diagonals bisect each other at 90 degree. After that you have to show this calculation, because we need to show that the BD passes through center O. So that's why we need to find the coordinates of O. So always shorter diagonal, that's going to be even. So we find the midpoint of AC, that's going to be midpoint of AC, that's going to be a coordinates of O. Right. I was recording video, but I was thinking I already done the calculation, but I see now the my camera was off. I put it on now, so I just want to show you what I did. So we have we have to find the gradient of we have to find the midpoint of AC, and the midpoint of AC is 4 comma 5 and 1 comma 5, and that is the coordinates of O. Must remember the short, always find the shorter diagonal. You must find the midpoint of the shorter diagonal, and that's gonna be the coordinates of O. So because the shorter diagonal is even, so now we need to show that the BD passes through O. So now uh, we need to find the equation of BD. So we're going to use the formula y minus y1 is equal to mx minus x1. This is a formula you also going to find in your formula sheet. And earlier we found already the gradient of BD, which is equal to 1. So we have the gradient of this line. So y minus y1, the gradient we already got the 1, and x minus x1. Right. So we have the gradient of this line. We already found earlier the gradient of BD, which was 1, and now we plug it into this formula. So the gradient we got 1. Now we need to we can substitute one of the coordinates B or D to find the equation. So I decided to substitute D. So for instance, I'm going to substitute D. You can even substitute B, the answer will be the same. So we'll substitute coordinates of D, which is 7 and 4, 7 and 4 into this equation. So it's x and y. So y minus 4 is equal to 1 is, we're not going to write, or you can write, doesn't matter, x minus 7. So this has become y minus 4 is equal to multiply the x minus 7. Now we need to find the y. X minus 7, negative 4 become positive 4, and then y is equal to x minus 3. So this is the equation of the BD. So we have the equation of BD. So now we need to substitute. Now after this we need to substitute O. Remember we have O earlier, midpoint of AC 4 comma 5 and 1 comma 5 into this equation. So this is your x and this is your y. So now, so y is 1 comma 5 and x is 4 comma 5 minus 3. So this is 1 comma 5 and this side as well 1 comma 5. So the left hand side is equal to right hand side. So which means the BD bisect AC perpendicularly. So therefore we say A B C D is a kite, and the reason we say because uh, BD bisects AC perpendicularly. So we prove this one. Just quickly recap. So we take the uh, gradient of AC and the gradient of BD, and we multiply, and the answer is equal to negative 1, because we need to prove that the both diagonals bisect each other at 90-degree perpendicular. So therefore we need to show that BD passes through O. So we need to show this one, because the longest diagonal, this diagonal long one, and this is a short one. So always short one gonna be even. So we take the midpoint of AC, and then we find the coordinates of O, and that coordinates we're gonna use to find the equation of BD. So we found midpoint of AC, and then we find the coordinates of O, and now equation, we need to find the equation of BD. So the equation of BD, we're going to use this equation of the to find the equation of the line. We're going to use this formula. It's going to be on your information sheet, and the gradient of BD we already found earlier, so we have 1. So we substituting this formula, and then we're going to substitute D or B, one of these coordinates, and to find the equation of the line BD. So we substitute D, and we find the equation of the line, which is x negative 3. We plug all these value into this formula, and now we need to substitute now O, which is the coordinates of O, which is x and y, into this equation. So the to y is 1 comma 5, place of x going to be 4 comma 5, and now we can see left hand side equal to right hand side, which means BD passes through O, the midpoint of AC. So now we can say, therefore we can say ABCD is a kite, because BD bisects AC perpendicularly. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.